Hello and welcome to another IoT Central webinar. I'm David O'Hara and I'm the Managing Director at IoT Central. I'd like to start by thanking our sponsor, Ground Control. Ground Control is a leading supporter of the IoT Central community and we are grateful to have them as sponsors. Today's webinar is titled, Can 3GPP Standards Progress the Adoption of Satellite IoT? Now I'd like to introduce our speakers. Alistair McLeod is the Chief Executive Officer at Ground Control. Joining him is Oliver Potter, the Chief Operating Officer at Ground Control. Gentlemen, when you're ready, let's get started.
All right, well, thanks, David, and it's great to be here for you at IoT Central. I think a pretty interesting topic for today. Can 3GPP standards progress the adoption of satellite IoT? There's been a lot of talk about convergence of terrestrial, non-terrestrial networks, turning the world of IoT upside down. And 3GPP, which of course is the cellular standards body, since release 17 of 3GPP, there's been even more talk about it. So is it going to accelerate standards-based IoT across the world of terrestrial and non-terrestrial networks? That is our topic for today. But a couple of intros first, if that's all right. Starting with myself, Alistair, I'm the CEO at Ground Control. I joined in 2020. Previously, I did a company called Teralytics, big data machine learning company. But I've been in telco and tech, well, a long time now, and actually founded the first machine-to-machine sales team at Orange back in 2002. When I'm not doing tech things, I'm a keen sailor, I'm a lapsed private pilot, and I'm also a tech geek in my spare time. Ollie?
Hi, I'm Ollie. I'm the COO at Ground Control. I've been here since March 2022. I've been in the IoT space for a decade, both within O2, Telefonica, and at TruePhone as well. Outside of work, you might find me on the touchlines of a football pitch, coaching under 12s or under 10s and trying to get them to victory.
All right, so we're going to start with the current state of satellite IoT, because of course it's not a new field, but we're going to cover the current state of satellite IoT first. Then between Ollie and myself, we're going to look at challenges for new entrants that might be barriers to the accelerated proliferation. Ollie's going to cover proprietary versus standards-based and give some predictions for the future. So that's our agenda for today. And starting with the current state. Now, Ground Control is very established in this space. It's essentially what we do for a living. And of course, although there's only a small number, there are some very established satellite IoT providers today offering very high quality services. We do a lot with Iridium and Inmarsat. Within Iridium, going all the way back, they have satellite switch for IoT, a service called Rudix. There's a current generation technology called short burst data, which is mesh format. New one coming out this year from Iridium, IMT, message transport, which will be higher capacity messaging. And they also have narrowband IP services on their Certus platform. So they've got quite the array there. With Inmarsat, also a major partner of ours, going back a while, but most famously for their Inmarsat Data Pro service, IDP, and now the new generation service, OGX, coming out, as well as, of course, the ubiquitous BGAN, M2M, broadband global area network, machine to machine. Viasat have offerings, Geo Networks offer IoT or machine to machine or SCADA. We sell a service called TSAT over a Geo Network. So small number, but plenty of services out there today. And that's really been the state of the world for a while now since satellite IoT became a thing. So what's changing at the moment that leads to this discussion? This is the biggie, not the only one, but this is the biggie. The launch costs have fallen dramatically. So in the last 40 years, launch costs per kilo have collapsed by 3 orders of magnitude. And in fact, just in the last decade, the launch costs have dropped by 90%. So it was $100,000 per kilo 10 years ago to launch a kilogram of space payload, and now it's 1,000 kilos per kilogram, and you can see where the trend is going. So that is definitely a big part of it. But that's by no means the only part of the cost structure that's driving this change. There's other changes as well. If you're going to throw up hundreds and hundreds or thousands and thousands of satellites, you can afford to build in some obsolescence and just assume that some of them will fail, which you couldn't do if it had to last 20 years and you only had one satellite. So now materials are cheaper, which means technology build costs are cheaper, and all of that is driving down the cost of putting it up there and putting more of them up there and creating an overall lower cost structure. And that takes us to the entrance that we're really talking about when we talk about today. You can throw this stuff up for less, you can build your satellite for less, and that is definitely attracting new entrants. They've been tens, if not hundreds of new entrants trying this, many of whom have launched some satellites. Some have already failed. These are just a few names, Satelliot and Swarm and so on. But definitely, these substantially changed economics, at least at the system level, are attracting new entrants. So is it true then that these new economics are indeed going to drive this sort of transformation towards the convergence of NTN and non-terrestrial networks? Ollie, over to you.
So you've got this opportunity now, you've got much lower launch costs, so you conceivably can put a new IoT constellation in the sky. And actually over the last 10 years, about 30 or 40 different companies have announced that they want to have a go. The next challenge then is, well, what spectrum are they going to use in order to communicate from the satellites in space with the devices on the ground? And the spectrum is the sort of the allocation of the airway that enables those devices to talk to each other. And for IoT, you need to be in the kind of sweet spot area, which is typically the L and the S band spectrum. So that's 1 to 2 gigahertz. If you have a much higher frequency, you're using more power and it will drain batteries and it kind of can't work that way. And if you're using much lower frequencies, there's just simply no capacity at all and you can't put much data through it. So your sort of first port of call might be the UHF, VHF frequency. It's probably too little capacity. This is sort of 50 to 500 megahertz range. This is where your sort of FM radio or your TV at home or GPS, those are the sort of frequencies this works at. And the challenge here is there isn't enough capacity. You can get a global service potentially quite easily, but as soon as you reach a little bit of scale, you're going to run out of capacity simply because there isn't enough UHF and VHF bandwidth in order to put those messages through. So we did see a few play in this space. Probably the most famous one was Swarm, but that has since really stopped taking on new customers, has reached a kind of capacity problem and can't move forward. So for now, reject that, and that's not working. The second area then is, well, actually, who has lots of spectrum? And of course, it's the land-based cellular mobile networks. They sit on spectrum that sits at the sort of 800, 900 megahertz, so in a nice sweet spot, all the way up to a few gigahertz as well. But you've then got to persuade a mobile network to give up a proportion of their spectrum in order to have that broadcast from a satellite to provide that service in the country that they're in. And for some countries, you can see that makes a lot of sense, where they have large land masses that aren't covered by cellular networks. You know, the USA is a clear good example of that. But for many countries, and we sit here in Europe, you know, your mobile phone doesn't work in London Waterloo or Gare du Nord because there's just simply too many people going through there, and there isn't the spectrum to provide that cellular service on the ground. So the challenge of a mobile operator giving up spectrum to provide a sort of rural broadband or sort of rural IoT service in rural areas is somewhat challenging. So we see that working for some countries, and particularly to help a sort of consumer-based direct-to-device messaging service, that might work. I imagine, you know, the USA is obviously a place that could work, Canada, Australia, some of those sort of markets. But for IoT, where you want the service to work all around the world, it's hard to see how borrowing spectrum from the mobile operators will make that work for a global service. Then the final one on this then is the L and S band spectrum that's already being used and already been allocated to the existing satellite operators. So Inmarsat, Iridium, Viasat, Thuraya, those players sit on that spectrum. And you know, you can go then and borrow some of that spectrum or use their satellites to broadcast your service to create that service for end users. And that absolutely is where some players have gone. And the advantage of this one is you do get potentially a global service if you get one of the global spectrum holders, and you also get the landing rights in order to be able to use that around the world. The challenge, of course, is there's lots of businesses and customers already using that spectrum, and there isn't that much of it. So recapping from where we are, you've got lower launch costs, and now you've worked out how you're going to get a little bit of spectrum. You've next got to try and grow a business with it. So handing back to you, Alison.
Right. Yeah, exactly. So where are your subscribers going to come from? Now, obviously, globally, the vast majority of the money is that's being spent on subscriptions is going into broadband right now, and what you're left with is 2 to 3% for your IoT. IoT, by definition, tends to be lower revenue per subscriber. Otherwise, the business cases don't cost in. And what we're now talking about is low cost IoT. So we're almost doubling down on the low cost thing. So we know we are consciously and deliberately with these new models pushing the revenue towards that low end. And when you start doing the maths, if you work out, I don't know, $5 per month or $10 per month, how many of those have you got to sell before you start getting anywhere near getting back the cost of the satellites that you put into space, building them and launching them, even if the costs are a lot lower than they were, you quickly realize that you really need to get mass scale adoption before this is going to sort of start to work. So new entrants, even with venture money or with institutional money, once they've got the money and they've started to build a network, they're going to need to grow the subscriber base very quickly. And where are those going to come from? Again, if we're talking about new use cases, and then we're talking about wanting to keep the costs down, then you also need to keep in mind that churn is expensive. So the reality is that most of the new subscriptions will have to come from new cases that aren't viable with the existing technologies. They will be at low cost, and they'll have to find new users rather than cannibalizing existing users. And there's several challenges all heaped on there, which means that the challenge to acquire subscribers definitely isn't to be underestimated. And we think we did a small back of an envelope calculation about how many subscribers network X would have to get at $10 a pop to pay back the network, and the answer was a lot. You can do the maths for yourself. So then that brings us to, let's look at the comparison between the technologies themselves.
So everything we've been talking about so far has been with really a kind of proprietary standard. A particular network's got a waveform and a set of modules that would work for that network. And actually, when I mentioned earlier the sort of 30 or 40 IoT satellite constellations that announced, most of those were a proprietary waveform. And you add the challenge Alistair just talked about, getting those new subscribers and new growth, and you had this potential choice of these new networks. It was clear why you couldn't get anyone. It was hard to choose which one of these was going to work. So which really then moves us on to standards-based. So the proprietary hasn't worked because it hasn't fundamentally changed the economics, and you haven't been able to kind of grow that base. But does standards-based change the game? So the idea here is, while a lot of the kind of technical side of it is the same, it's still satellites in space. It's still satellites that might be in a geostationary orbit or in a low Earth orbit. What you have agreed though now is it's got to operate through a particular standard. And what that brings in is a change to competition, and therefore then the commercial model and commercial assumptions that might go with it. So first of those is, well, I'm going to roll out my satellite IoT project, and I don't know what the price might be in 5 or 10 years' time. Well, if I'm on a standards-based network, then the theory is there might be more than one of those, and I might be able to roam my base between one and the other. And as a consequence, I have a greater confidence over the pricing that there might be, that I can put into my business case rolling out in the future. The other side to it that might also be true is I don't have to buy my modules or my chipsets from the one provider now. I could buy a standards-based one from a number of different cellular module makers out there. So again, I might reduce the device price slightly, albeit the module itself is generally not the biggest part of the cost. So it's not a game changer in itself, I don't think, from that perspective.
No, and exactly, when you look at the sort of, when you look at the more broadly at the whole terminal cost, for this to be truly transformational, we need to be seeing 60, 70, 80, 90% cost reduction in the overall system, not just the module. So as you rightly say, the terminal is much more than just the module. Nobody buys a Qualcomm chip to make a phone call, you buy a telephone. So when you look at the broader picture, we need to be thinking about the economics of the whole thing, and we need to be seeing some big benefits, not only at the module costs, but at the device level and in fact at the network level.
I think absolutely you're right, Alistair. So we've got now the theory of a bit more competition. a non-transformational but some reduction in the device cost. But you've also then got some of the other technical hurdles to overcome. So the narrowband IoT standard would use a non-IP data delivery service, which is a messaging service, much like the messaging services that Iridium and Inmarsat use today. But that's not a messaging service that's used today by any of the ground-based narrowband IoT cellular networks. So you've now got a complexity. You're going to need a modern module that's doing release 17. You're now going to have to adopt NIDD, so the non-IP data delivery standard. And then will that work with the ground-based cellular networks, some of which have rolled out different standards as well. Some have power save modes, some don't. So you've got a lot of complexity that's got to be ironed out to kind of make this work over time. But the theory is there's a thread there, isn't there, that a bit more competition, a bit therefore a confidence over pricing in the long term. I think it's probably the right word. Right, should we move forward to kind of, I guess, our predictions in the near future? So on the top right of this slide, we have already today, we have some fabulous networks doing some brilliant IoT business. They've got global coverage, low latency, good allocation of spectrum, providing a really robust service. We have customers in the most extreme environments all around the world that are using this to kind of track high value assets or people or whatever it might be all around the world. And then you've got this idea that we can kind of have this lower price. And I think certainly what we've seen is some of the UHF and VHF networks that have come up, but then reached a capacity problem, and therefore haven't delivered the kind of growth that everybody wanted. And I guess you've now got some of the standards-based companies talking about this holy grail of new lower pricing. And I think what we've got to understand is there's a line across this chart from the bottom left to the top right, and whether that line can be reduced in height slightly and reduces the overall cost is the conundrum that will have to play out over the coming years. Because in order to offer a scale standards-based IoT solution, you've got to be using the spectrum, the L and the S-band spectrum that's already being used by the existing operators. So therefore, you've got to somehow densify that network by putting millions more satellites up and bringing them closer to the Earth, or you've got to be using what they've already got at just a lower price. But why would the market move in that way? So we think standards-based, it will help, and we'll do that in the future. But it's really hard to see how we get there quickly and what it really means for the market beyond the marketing shouts that are already out there.
Absolutely. So just to bring us right back to where we started, then, can 3GPP standards progress the adoption of satellite IoT? I think the conclusion we're drawing is it depends. I think nothing major is going to happen in the very near future. You need both transformational breakthroughs in technology to bring down the unit cost of the tech and transformational breakthroughs in the commercial models. And to do that, as Ollie says, you need to be thinking about spectrum and landing rights, as well as the module and the technology itself. So it's a very exciting space, and we're definitely watching it closely. There is great tech out there today, of course, for sure. There's no doubt in my mind that some of these new entrants will succeed with something interesting and something different. Whether it accelerates the adoption of satellite IoT in a mass and prolific way, or whether it's an incremental sort of slide from one to the other, or a mix, I think time will tell, but it's certainly going to be interesting. So we're going to be doing a series of these webinars with the IoT Central, so keep an eye out. Please do check back. We look forward to seeing you again soon. And meanwhile, back to you, David.
Thank you, gentlemen. This brings our webinar to a close. I'd like to thank Alistair and Oliver for their insightful presentation, and Ground Control for sponsoring today's event. You can view more webinars at iotcentral.io. Thank you for watching.